All right, so now moving into the last little bit, we've seen in the previous questions how things break down and what they turn into. Now we want to look at basically the rates at which they do that. So we have this thing called a half-life, and so a half-life is the statistical amount of time that it takes for roughly half of your material to decay and turn into something else. So I used radioactive gold as an example because I thought that sounded interesting. Gold is, precious on its own, and radioactive gold, probably wouldn't want earrings made out of that, but just sounded interesting, appealing to me. So I grabbed that. Has a half-life of 2.7 days. I'll write that up here because it got cut off. All right, and so our formula, sometimes this is an N for a number of particles, sometimes it's A for an amount. It can be a few different things, but I've got N because I grabbed that from the book before. Is N naught, so think NaUGHT, like all for nothing, for zero. This is the N at 0 time, so basically the beginning amount. And I've modified this formula slightly to help us avoid some of the weird calculator functions that sometimes pop up. So normally you've got an E here, which is a special number kind of like pi. It's 2.7172, something like that. Um, but we have a little bit of an easier time if we just use 2. And then I also think it helps think of half-life because, cutting by 2, dividing by 2. But anyway, slight liberty I've taken with the formula here. And then the exponent is negative t. So little t is your total amount of time. And then this is divided by capital T. Capital T is like your time period, like when we had, frequencies and waves and things that were repeating. Um, because the half-life is repeated over and over again, then it's a capital T. Sometimes even has a little 1/2 subscript, but I don't have a very good way to write that into the formula sheet, so that's why I made it look like this. Now this one in particular, because we're looking for the portion remaining, um, it turns out we don't care how much we had. You could work it down and then divide the two answers, and you would be doing extra work. What we can do is we can actually kind of solve for this as a combined factor. And so the ratio, and to really draw attention that we're solving for this together, I'm going to put it in parentheses, is equal to just this factor on the end where we have 2 raised to that really weird exponent. So little t on top and big T on the bottom. All right, but that's actually pretty easy to do because we just want to know we've got 2 raised to the negative 10.74. Now these are days and days, so they will cancel. I'm going to save a little writing down here. Divided by the half-life, which is that 2.7. You'll have a button that'll help you raise something to weird exponents. So it may say, like, it may be a little caret button, like a sort of tip of an arrow. It could be X to the Y, a couple of different things. But if you find your calculator command, it should be pretty easy to do. And then overall, this gives us about 0.06347. There's 5 or 6 decimals on the answer key on this one, I think.